Normal distributions have a variety of x-axes or values. You could imagine if we were measuring men's heights. Men's heights are typically have a mean of about 69 inches and then a standard deviation of about 2.5 inches or so. Compared to another normally distributed factor, weight, cholesterol, salaries are normally distributed but tend to have a skew. Other factors, but they're measured in different units. They have different possible ranges. Their standard deviations can be quite varied. So in order to compare these distributions, we need to standardize them, and we create what is called a z-score. The z-score translates raw scores into standard scores by averaging out the mean and the standard deviation. It's nothing more than just a relabeling method. So we go from something in some type of units and normalize it to get standard scores. The standard normal distribution has a mean of 0 and a standard deviation of 1 for all distributions. It doesn't have to be symmetric or normal, but if the distribution isn't normal, then you can't use normal tables to find the probabilities, and we're going to discuss that in a minute. The equation to calculate a normal distribution is here, where the z-score equals the sample mean, which is x, minus the expected or population mean, and then the divided by the standard deviation. So let's look at an example. Let's say that Patty scored 62.5 on her exam. The average for the class was 50. And the standard deviation was 12.5. The scores were normally distributed. First question we want to ask is how many standard errors, or z-scores, was Patty's score above the mean? So we would use this equation where her sample was 62.5. The mean for the class was 50. And the standard deviation for the class was 12.5. We can say in this case that Patty's score was 1 standard deviation, or 1 z-score, above the mean. Now, let's say that she scored below the mean. We could still calculate the z-score, but in that case, the score would be a negative value. Those values of z-scores can go anywhere from negative infinity to positive infinity, but we can see that most of the time those values are somewhere between 2 standard deviations above and 2 standard deviations below. Second question, what percentage of the class did better on the exam than Patty? Well, we can do basically 3 methods. The first method is approximating. We can see that Patty's score is here at 62.5. So approximately 13.5% plus 2.5%, which gives us 15%, of the class did better than, 16% did better than Patty. A more appropriate way is to use what are called distribution functions. The most common one that we're going to be using in this class is the norm dist function. This is a way of getting a probability from some value that is less than or more than the mean, and it always measures that probability from negative infinity to that value. So, for example, if Patty's score was 62.5, in Excel we'd use the function norm dist. The first question it asks is, what is Patty's score? What is the mean? What was the standard deviation? And then it would ask us a final question. Excuse me, that should be an R. Is it a continuous probability or a discrete probability? In this class, we will always use continuous probabilities. So we're going to use this value of 1.